6th class, Andhra Pradesh State Board, lesson number 14, Movements in Animals. Movements in animals. We can perform different types of movements with the help of muscles and bones. Muscles walk in pairs. When one of them contracts, the bone is pulled in that direction and the other muscle of pair relaxes. To move the bone in the opposite direction, the relaxed muscle contracts and the first one relaxes. Tendons. Some muscles have round, wide, rope-like fibers at their ends that connect them to the bone. These fibrous structures are called tendons. Bones, skeleton. The different bones of different body parts combine together to form a single structure or system. This structure is called the skeleton. It consisting of bones of fingers, skull, lower bones of arm, clavicle, upper bones of arm, ribs, pelvic girdle, thigh bone, knee bone, calf bone, bones of toe. Ligaments. Two bones are joined together in a special way by fibers. These fibers are called ligaments. Jawbone. This bone is connected to skull. This helps in chewing food. Clavicle, shoulder bone. The raised bone at the shoulder is called clavicle and the bone behind it is the shoulder blade. There are two bones protruding from the shoulder called shoulder bones. The ribs. The ribs are curiously bent and join the chest bone and the backbone together to form a box. This is called the rib cage. Some important internal parts of our body, such as heart, lungs, lie protected inside this cage. Backbone. A long structure running down the middle of our back is called the backbone. The small bones that make up this backbone are called vertebrae. The spinal cord passes through the vertebrae of the backbone. Pelvic girdle. We have pelvic girdle below the waist. This structure is made of pelvis bones. They enclose the portion of our body below stomach. This is also the part you sit on. Skull. The skull is made up of many bones joined together. It encloses and protects the brain. Flexible bones, cartilage. Some part of the ear and nose are soft and others are hard. The hard parts are made up of a structure called cartilage. This is also a bone, but it is flexible. Different types of joints. We can move various parts of our body because of joints. There are different types of joints in our body to help us carry out different movements and activities. Ball and socket joint. A joint made by fitting a ball into a socket is called a ball and socket joint. In this joint, a bone can rotate easily in all directions. Joint between the shoulder blade and the bone of your arm is an example for ball and socket joint. Hinge joints. Hinge joint is a joint between bones that permits motion in only one plane. Example, elbow and knee. Neck joint. Neck joint is different from both hinge joint and the ball and socket joint. This joint helps us to move our head up, down and side to side. But we cannot rotate our head totally. Neck joint is a type of joint called pivotal joint. Fixed joints. Some joints between bones in our head can't move. Such joints are called fixed joints. There is a joint between the upper jaw and the rest of the head. It's a fixed joint. Locomotion in fish. The body of the fish is streamlined. The shape is such that it allows the fish to move in water easily. The skeleton of the fish is covered with strong muscles. While swimming, muscles make the front part of the body swing towards one side, while the tail swings its body towards the opposite side. This creates a jerk and push the body forward. A series of such jerks help the fish swim forward. The tail fins also aid in this movement. Locomotion in birds. Birds fly in the air and walk on the ground. Birds can fly because their bodies are well suited for flying. Their bones are hollow and light. The bones of the hind limbs are typical for walking and perching. Bony parts of the forelimbs are modified to hold muscles of flight, which is used to move the wings up and down. Let us see a small video regarding locomotion in birds.
Huh?
Locomotion in snake. Snakes have a long backbone and several muscles. Usually, the snake's body carves into many loops. Each loop of the snake gives it a forward push by pressing against the ground. This helps the snake move forward very fast. Let us see a small video regarding this.
Snake locomotion has always been somewhat puzzling to scientists. Some have speculated that snakes use leverage by exerting force on resistance points. That is, they push against rocks, branches, and other surface irregularities. But that doesn't explain how snakes navigate so swiftly in sand and over slick roads. Recently, it was discovered that snakes also make use of directional friction and weight distribution. Like most people, you probably think snakes are slimy. So how do these smooth, scaled reptiles generate friction? Well, contrary to popular belief, snakes aren't slimy. In fact, they may even feel a bit rough. Snake scales are smooth to minimize the forces of friction when they slide forward. Conversely, when snakes slide backwards or sideways, the overlapping scales, which resemble roof shingles, dig into the ground, causing frictional resistance to occur. If the friction exerted by the snake is equal in all directions, snakes just oscillate in place, meaning they'll go through the motions but won't be able to go anywhere. The scale's frictional anisotropy, or resistance to sliding in certain directions, helps the snake push itself forward. Also, scientists have discovered that snakes, through muscle movement, can change the angle their scales meet the ground. A larger angle generates more friction, while a smaller angle generates less. Weight distribution is also important in snake locomotion. If you closely examine a moving snake, you'll see that their body doesn't always remain in contact with the ground. Instead, snakes lift parts of their body off the surface to direct their weight on specific points. This is comparable to how humans shift their weight from heel to toe in order to run faster. It still isn't completely understood how snakes move. But it's important to keep learning about this because there are so many potential applications.
locomotion in snail. In snails, a thick structure comes out of an opening in the shell while moving. This thick structure is its foot made of strong muscles. The wavy motion of its foot is the reason why a snail moves slowly. Let us see a small video regarding locomotion in snail.
How do snails move? Well, snails have a highly muscular foot that is adapted for traveling over hard surfaces. So snails such as this land snail move by gliding along their muscular foot through succeeding waves of muscular contraction that move up and down the foot from their tail to their head. Now these waves of contraction can be clearly seen when a land snail is crawling on a transparent surface such as a window. Snails also secrete mucus to help prevent desiccation and drying out. And mucus also helps it to move by reducing friction, making the ground a slippier and easier surface to travel on, meaning that snails can even crawl over sharp objects such as razor blades without getting injured.
Movement or locomotion is an important function in every living organism. By this lesson, we can learn that bones and muscles help us perform different movements and activities.